No. Yeah. So question 6, question 1. Ask you which one of the following species is a bronze state acid. Bronze state acid. Which one can be bronze state acid? So first of all, what means a bronze state acid? Can provide a proton, right? Provide a proton, you need at least one proton there. If no proton there, proton is hydrogen ion, right? If no proton there, how can be donate or give off proton, right? So clearly, this cannot be. No hydrogen ion there, right? This also cannot be. Now you have 50%, either this or this. 50%. If you close your eye, you select one of them, you have 50% chance. Then compare NH3 with NH4, which one likely provide a proton? Of course, NH4 plus. NH3, it's a very famous weak base, right? Ammonia is a weak base. NH4 plus is NH3 bind with one hydrogen. This could be lost. So this is only one choice. It's D. This bonded hydrogen ion can be lost, serve as a weak acid. Are you okay now? Okay. Then question 2 asks you which one is a conjugated base of H2S? Which one is a conjugated base of H2S? First, the acid base is a conjugated pair, right? So conjugated base of H2S, this means H2S lost one hydrogen ion. H2S is acid. Lose one hydrogen ion becomes conjugated base, right? So clearly these two cannot be. This is H2SO4. This is H2SO4 minus. This is not directly related to H2S because you have actual elements there. These two cannot be. Then left over these two. Conjugate base of H2S is lost of one hydrogen ion, so clearly this. If this one, this is a conjugated base of HS minus, because this one lose one more, becomes this, right? So this next step. So this is your answer. Because H2S lose one hydrogen ion, left over one, this is a conjugated base. This is the acid. Get there? Okay. Again, listen carefully. We're approaching the end of semester. Only 3 weeks, except today. Only 3 weeks class left. Question 3. If a solution has pH 5.6, the solution is pH 5.6. Ask you, this solution is acidic or neutral or basic solution. It's a very clear answer, right? So pH maximum 14. If pH is less than 7, this is acidic. pH at 7, neutral. pH higher than 7, basic, right? Then pH 5.6, less than 7, acidic. No question about it. This is acidic solution. Question 4. Which of the following statement is true regarding a 1 molar solution of strong acid? Be honestly, this is a little harder, so you need to understand the chemistry about the acid base clearly. This is harder than question 1, 2, 3. Oh, this is huh? Sorry, question 4. Oh, I have to see here. Question 4. First of all, this is strong acid. What means strong acid? Strong acid means in water system, right? Most acid base are always in water system. That means completely break down into hydrogen ion and so if this is 1 molar strong acid HA, then finally 100% break down into hydrogen ion and A minus. No this molecular left. That means a strong acid. If you understand this process, then clearly this is your answer. Why is this not the answer? Because hydrogen ion 1 molar pH is not a 1. pH is negative log of hydrogen ion concentration, right? Negative log of 1 is 0. pH is 0. Okay, this is not a pH 1. It's if pH 1, the hydrogen ion concentration is 0.1. Negative log of 0.1 is 1. Right. So this is a little bit harder than question 1, 2, 3. Yeah. So again, a strong acid means in water system completely break down into hydrogen and ion. No molecular format left. No molecular format left. That means this is not correct. This is the HA formula, molecular formula, concentration still 1 molar. No. This becomes 0 for strong acid. Okay. Then how about this? Then clearly there's only 1 hydrogen and 1 A minus. These two exactly the same, right? So this is also not correct. So your choice is only C. Are you okay for this? Question 5. Which of the following salt solution in water, water means aqueous solution, is an acidic solution? or aqueous solution. Let's label AQ. Or aqueous solution. This means in water. Uh, we didn't start.
No, it's not showing.
Oh, okay. Yeah. Sorry, I didn't switch it to two. Okay, so which one is an acidic solution? This is all salt, right? And by the way, do you remember what it means of salt? Salt comes from acid with react with base. So any salt is ionic compound. You have cut iron and on iron. And the cut iron not include hydrogen. If hydrogen are there, this acid. On iron not include hydroxide ion. Because if hydroxide ion are there, this is base. Also not include oxide. Any other ionic compound you can think about that is salt. If salt is an acidic solution, that means this salt comes from strong acid react with weak base. Right? This is acidic solution. If this salt comes from weak acid react with strong base, that were basic solution. If this salt comes from strong acid react with strong base, then this is neutral. Good example is here. I don't need it, right? Sodium chloride. This comes from strong acid with strong base, right? You can think about this comes from sodium hydroxide, strong base. Hydrochloric acid, strong acid, right? So strong acid, strong base reaction give you a salt which is neutral. And this is another example. Strong acid, strong base. This comes from KOH plus HBr. Strong acid, strong base. So which one is acidic solution? So we need to think about which one comes from strong acid react with weak base. A strong acid react with weak base give you salt is acidic solution. So you have only two choices, right? This comes from strong base, sodium hydroxide. Weak acid, acidic acid is a weak acid, right? Strong base, weak acid. This will result basic solution, right? Then this is only one left. This comes from strong acid, HCl, react with weak base, ammonia. So weak base, ammonia, react with strong acid. This gives you acidic condition, so strong acid. Ammonia is a weak base. Chemistry, sometimes you need to memorize some. So ammonia is a weak base. Keep in mind, this is a very common weak base. Okay. So clearly, this is your answer. This salt comes from strong acid, react with weak base, so give you acidic salt. If this salt comes from strong base, react with weak acid, clearly this is basic solution. Okay. The rest is calculations you need to work. Okay. Each step should work in step. Each step worth some point. Question 6 asks you calculate hydrogen ion concentration of the solution. pH is 3. Is this easy? It's very easy. And I remember I shared one, picked one from homework, shared this in a class right before the quiz day. Right. This is a quiz is Wednesday. I shared up in Monday's class. Okay. So hydrogen pH is negative log of hydrogen ion concentration. Then hydrogen ion concentration is 10 to the negative pH. It's the power. So this is 10 to the negative 3. 0.004. Or even if you keep this 10 to the negative 3, I'll give you full credit. Unfortunately, not everybody makes this correct. This is I'm really disappointed. This is the easiest calculation. Are you okay now? I can tell you we will have similar in the test. Because this is very basic, we cannot keep it, skip it. If I put this in the test, this means I send you this credit. Cannot be easier than this. Question 7, little harder. We cannot everything is so easy. Okay. Question 7, be honestly, is a little bit harder. So ask you how much NaOH solid in grams is needed to prepare a solution 500 milliliter with pH 13. Ask you how much solid NaOH needed. Because ask you how much NaOH is in gram, that's solid. So prepare a solution. So you need when mass, then dissolved in water, make the final volume with this concentration. This is pH that actually tell you you need to convert it to concentration. Since this NaOH is a base, NaOH dissolved in water, this is a strong base. The actual process is this. You add some water there. We don't know how much water needed added, right? Then becomes NaOH solution. This is strong base. So this strong base will completely break down into hydrogen, sodium ion and hydroxide ion, right? And from this pH, we can figure out what is hydroxide ion concentration, which equals to initial NaOH concentration, because the strong base completely break down into this hydroxide ion. So if you initially have 1 molar NaOH, then it will give you 1 molar OH. So from this pH, you find the OH concentration. Then this will be initial NaOH concentration. Then from concentration together with volume, you can find the moles. Then from moles, find the mass. Right? In Chem 1, more is right in this place many times. So mass to moles is mass divided by molar mass. If you have moles, you want to find the mass, like here. Is mole multiplied by molar mass. Right? So for this idea, first of all, we need to convert this pH into hydroxide ion concentration. You need to think about the pH plus pOH always equal to 14, right? Then pOH 14 minus pH 13 is 1. pOH is 1. Then similar as I remember somewhere I wrote here. And to the negative erased. Oh yeah, actually it's here. Okay. So similar as pH, the pOH is negative log of OH. Then OH equal to 10 to the negative pOH. Right? So OH concentration will be equal to 9 to the negative pOH. 10 to the negative 1 is 0.1 molar. Right. So OH concentration is 0.1 molar. This means you need to prepare NaOH solution is 0.1. This tells you your initial NaOH concentration must be 0.1 molar because of one NaOH give off one OH. So these two must be equal. I know this is somewhat confusing is this is strong base. Strong base in water. No more this exists in water. Completely break down into this one. What I write here, this means initial concentration of NaOH. Because we want to calculate how much NaOH solid needed. We need to go through this. Okay, so even though I write the NaOH concentration 0.1 because we want 0.1 molar OH minus, right? But actually in the solution, no this exists because this is strong base, all break down into sodium iron hydroxide. But we do need this form for the calculation. Can you understand this idea? Sometimes you may see this is confusing. You see this is strong base and then no more this exists or becomes this. Use this form is just for calculation. So we need this initial concentration of NaOH. Now you have molarity, you have volume. You remember molarity? This we learned in Chem 1, right? Molarity equals to moles divided by volume in liter. We have molarity, we have volume. So molarity times volume in moles. Then from moles back to mass, right? But this volume must be in liter, so we need to convert 500 milliliter into liter. So 500 divided by 1,000 becomes liter. Then liter times molarity becomes more. Then from more to mass is more multiplied by molar mass. How can you get this molar mass? I provided you periodic table. Right? So you need to add sodium 22.9, O is 60, hydrogen is 1 together about 40. So hydrogen is 1.08. Okay? And sodium is 22.99. Just add 16 from oxygen. Approximately is 40. Okay. With a help periodic table, you can figure out molar mass. Then this is about 2 grams. This is solid hydrogen, sodium hydroxide needed. Okay, each step worth some point. If you should work, you figure out the pOH, you get 1 point. If you figure out the NaOH concentration, then you get another point. If you figure out the moles, you get another point. The final step. another 1 more. Are you okay with this? Then next one. A 0.5 molar weak acid is 20%. As you calculate the Ka. So you need a list how weak acid ionized, because Ka is this, right? So we need to figure out hydrogen concentration, A minus concentration, and molecular HA concentration to calculate the Ka. Then you need a list, a table. Initial 0.5 molar HA. This means initial concentration of HA is 0.5. And initially, nothing. Hydrogen A minus, nothing there, right? You can label it like 0. Initially, these two are 0, right? Then how much change? This is ionization. Here, 20% is ionized. That means 0.5 times 20%. This is critical. Can you understand? 20% ionized. This means wrapped 20%. Wrapped 20% of this initial concentration. So 0.5 times 20%. Then produce hydrogen, same, because this is all 1, right? 1 to 1 to 1. So this produce hydrogen also 0.5 times 20%. A minus also 0.5 times 20%. If you want, you can immediately give this 0.1, this 0.1, this negative 0.1, right? I'll give you easy number this time. Now, when this reach equilibrium, 0.5 minus 0.1, this is red, ionized, leftover 0.4. This 0.1, this 0.1, right? The initial 0, plus this, still this 0.1. Now, this formula here, hydrogen 0.1, A minus 0.1, HA 0.4. If you get here, even if your last final answer not correct, you get the most. Final answer only 0.5. Final answer is 0.5 or 2.5 times 10 to the negative 2, either one. Okay, again, this is step by step, should work. So if you list this, I give you 0.5. If you list this, give you 1.5. Another, the last one, this is one step. And it's one step because you don't have to give 0.1 separately. This is 0.1. Okay, 0.5, 1.5, 1.5. 0.5, 0.5, 0.5. Are you okay for this?